So let's continue with question number 5. The question there says, find the maximum volume of a right circular cylinder that can be inscribed in a cone of altitude 12 centimeter and base radius 4 centimeter if the axis of the cylinder and the cone coincide. So I've just drilled what they asked us. Now this is the cone. This is the cone and this is the cylinder. The axis of the cone and the cylinder coincide. So I have that here. And now this from here to here should be the height of my cylinder, which is what I'm looking for, because I'm asked to find the maximum volume of the cylinder, not the cone. But they gave us the altitude of the cone to be 12 centimeter. That is the height. The height of the cone they gave to us is 12 centimeter, and the base radius of the cone is 4 centimeter. Remember, the radius is from the center to any part of the circumference gives us the radius. So from this center down to this part here gives us the radius of the cone. But the cylinder is inscribed inside of the cone, and we have to find the volume of the cylinder, not the cone. Now, first thing we are going to do, let's recall the formula for finding the volume of a cylinder. But we know that the volume of a cylinder V is equal to pi r square h. This is what we have. So let me just quickly call this equation 1. And now, we don't know the radius of our cylinder, and we don't know the height of our cylinder, but we know the height of our cone and we know the radius of our cone. So what we need to do is to find the radius and height of our cylinder. Then we can substitute it here to find the maximum volume of our cylinder. But now let's look at it this way. We have the height of our cone to be 12 centimeter, and we have the radius of our cone from this center to here to be 4 centimeter. But what I need to do is for me to find the height of my cylinder from here down to this part here. From here down to this part is the height of my cylinder. So how can I find the height of this my cylinder? If you look at it this way, let's look at it in form of a triangle. Let's look at it as a triangle. We have this right angle triangle from here down to this part as a right angle triangle, and we have another right angle triangle from this part down to this part again as a triangle. Now what we are having here, if we are to draw this triangle, we have something like this. We have something of this nature. We have this bigger triangle, and from here we have another triangle here. So this is what we have. And this part of this triangle is 12 centimeter. 12 centimeter. And the radius from this part to here is 4 centimeter from the question. So this is what we have. And this part from here to here, which is from here to here, is the height of our cylinder. While here is the height of the cone, and here is the base radius of the cone. So from here to here is the radius of our cylinder. From here to there is the radius of our cylinder. So now let's quickly find the height of this our cylinder. So let me first of all write this r here as the radius of our cylinder. Okay, from here to here is the radius of our cylinder. So we have it here. We have it here, not here. We have it here, r. If you observe, from here to here, it should be the radius of our cylinder, and from here to here is the radius of the cone. So we have from here to here to be our radius of our cone, and that is what we are looking for. So now, how can we find the height and radius from here? What we are going to be using, we are going to be using the idea of principle of similar triangles. We have a smaller triangle, a small triangle inside a big triangle. So to find any parameter, or let's say the height or the radius, we need to apply the idea of similar triangle, or the principle of similar triangle. And what is this principle of similar triangle? Let's see how we can use that principle. So using the principle of similar triangle. So we are going to use the principle of similar triangle. And now, how do we use this principle of similar triangle? We just take the height of the bigger triangle, 12, and you divide it by the radius of the bigger triangle. And the radius of this bigger triangle is 4. So we divide it by 4. And we equate this to the height of the smaller triangle H. And we divide it by the radius of the smaller triangle. Now, if here is R, what will be here? Here should be 4 minus R. Let's take note. From here to here is R, so here it should be 4 minus R, because we have this part here to be R. So from here, which is our smaller triangle, should be 4 minus R. So what we have here is 4 minus R. So you can decide to include it here. Here is R, so here should be 4 minus R, because the total here from here to here is 4 centimeter. So this is the idea of the principle of similar triangle. You take the height of the bigger triangle, 12, and you divide it by the radius of the bigger triangle, you have 4. The next, you take the height of the smaller triangle, H, and you divide it by the radius of this smaller triangle. And we have that from here to here is the radius R. So from here to here, should be 4 minus R. So that is how we have 4 minus R. And this is, let's call this equation 2. So next we need to do is to find H. Just make H subject of formula from there. You have to make H subject of formula. So 12 over 4 will give us 3. And this is equal to H over 4 minus R. So let's make H subject of formula. We have H to be equal to 3 into 4 minus R. So this is what we have. Our H, which is the height, becomes 12 minus 3R. So this is what we have, 12 minus 3R. But we know that the volume, recall that the volume is pi r square H. So we can substitute H into equation 1. So substitute H into equation 1. You have the volume will be equal to pi r square into H now becomes 12 minus 3R. So this is what we have. Now, if you take note, the volume now becomes a function of R. Initially, the volume was a function of R and H. Because we express H in terms of R, so the volume becomes a function of R. So we have V of R equal to, multiply this out, you have 12 pi r square minus 3 pi r cube. So this is what we have. But we know, recall that this is application of differentiation. This is actually the application of differentiation. So what we are going to do, we are going to bring out the idea of stationary points. We said that at stationary points, dy dx is equal to 0. We know that. But now this is now v now is a function of r. So if you differentiate this with respect to r, you have dv dr equal to 24 pi r minus, differentiate this, you have 9 pi r squared. But we know that at stationary points, dv dr is equal to 0. So we have that 2 pi r minus 9 pi r square is equal to 0. So this is what we have. Send 9 pi r square over to this side. We have 2 pi r to be equal to 9 pi r square. So observe now, we see that pi we cancel pi, r we equate one of the r. So what we have to this side, we have 9r being equal to 24. So that we have r to be equal to 24 over 9. So 2 into 3 into 24, we have 8, and 3 into 9, we have 3. So what we have is 8 over 3 as our radius. So our radius r is equal to 8 over 3 centimeter. But to find the maximum volume, we need h. But recall that h is equal to 12 minus 3r. H is equal to 12 minus 3r. So what we have here, h becomes 12 minus 3 into our r is 8 over 3. So we have 8 over 3. So our h there becomes 3 cancel 3, we have 8. 12 minus 8, we have 4. So we have h to be 4 centimeter. So since we have obtained the value of r and h, we can substitute it here to find the maximum volume of the cylinder. So let's quickly do that and see what we have. Let's quickly do that and see what we have. So V becomes pi into r. Our r is 8 over 3. So we have 8 over 3 all squared into h. Our h becomes 4. So this should be equal to pi. 8 squared gives us 64. 3 squared 9 times 4. So our V there becomes, we need to evaluate this and see what we have. If we evaluate this, we have the volume equals to 89.36 centimeter cube as our answer. So please take note, whenever they ask you to find maximum volume or maximum area, know you are using the application of differentiation by taking the derivative of the volume or the area as the case may be. Then you set it to be equal to 0. We are going to take the question number 5b. The question there says we should find the area bounded by a line and a curve. And the formula to find that area, because this is under application of integration. So the formula for finding that area is given as the integral from x1 to x2 of y1 minus y2 dx. Now the question now is, what is your y1 and what is your y2? Well, your y1 is equal to the curve itself. Your y1 is the curve, which is x squared, take note, x squared minus 9, and your y2 is the line, and the line there is 3 minus x. So this is what we have. Now to find x1 and x2, we need to equate the line to the curve. So let's equate the line to the curve. We have x squared minus 9 being equal to 3 minus x. So let's send 3 minus x to the left hand side. We have x squared minus 9 minus 3 plus x being equal to 0. So what we have here is x squared plus x minus 12 being equal to 0. So what we need to do is to factorize this. Look for two numbers. If we add, it will give us x and 1, and if we multiply, it will give us minus 12. And of course, those numbers are minus 3 and plus 4. So we have x squared minus 3x plus 4x minus 12 being equal to 0. So let's factorize. We have x into x minus 3 plus 4 into x minus 3 being equal to 0. So we have x minus 3 into x plus 4 being equal to 0. So here we have x to be equal to 3 and we have x to be equal to minus 4. Now your question now is, which is your x1 and which is your x2? Your x1 is the lowest value and your x2 is the highest value. So our x1 becomes between 3 and minus 4. The smallest there is minus 4. So we have minus 4 and our x2 becomes 3. So our area there becomes the integral going from x1, which is minus 4, to x2, which is 3, of y1 minus y2. So we have x squared minus 9, which is our y1, then minus y2. Our y2 is 3 minus x, 3 minus x dx. So we have our area to be equal to the integral from minus 4 to 3 of x squared. We have x squared. Then if you should open this bracket, you have minus 9 minus 3, which becomes minus 12. Then minus minus become plus x squared plus x minus 12 dx. So we have to integrate this now. So let's quickly integrate this. So let's integrate this. We have the area being equal to, if you integrate x squared, you have x to the third power over 3. Integrate x, you have x squared over 2. Then you integrate minus 12, you have this. And this, the limit there is from minus 4 to 3. So we have the area being equal to, remember, you substitute the upper limit and then you subtract from the lower limit. So we have 3 to the power of 3 over 3 plus 3 to the power of 2 over 2 minus 12 into 3. So this is our upper limit. So I'm going to put this in brackets and subtract it from our lower limit. You substitute minus 4, you have minus 4 to the power of 3 over 3 plus you substitute minus 4 to the power of 2 over 2 minus 12 to the into minus 4, and then you simplify. So our area becomes minus 3 raised to the power of 3 will give us 27. So we have 27 over 3. Then 3 raised to the power of 2 over 2 give us plus 9 over 2. Then to this part we have minus 12 times 3 will give us 36. So we have 36 here. Then over to this side, minus 4 to the power of 3, setting as saying minus 4 times minus 4 times minus 4 to give us 16. 16 times 4 give us 64. So we have minus 64. We have here we have minus open brackets minus 64 over 3 to this side. And what about here? We have minus 4 to the power of 2 give us 16. So we have plus 16 over 2. Then minus 12 times 4. Minus 12 times minus 4 give us plus 48. So we have plus 48 here. So we open the bracket. We have the area being equal to 27 over 3 plus 9 over 2 minus 36. Then the next one is minus minus plus 64 over 3 minus plus we have minus 16 over 2 give us 8. So we have minus 8. Then minus this becomes minus 48. So the area there becomes, let's simplify this and see what we have. So I'm going to use my calculator to simplify this. Using calculator to evaluate this, we have the area to be equal to minus 57.16. But take note, the area cannot be negative. So we take the absolute value of this answer. We take the absolute value, so we have 57.16 square units. So that is the answer to that given question number 5.